Continuing with section 2.7, here we have the example 3, and we are given two functions and we have to evaluate some quantities. And these are typical problems that you will see in the final exam and of course in class exam as well. So how do we do them? Well, we have learned the notation and the definitions. We just apply them. For a part, so we have a top and a bottom. So we work with each of them and then we simplify or combine in that. So the top is P composed with M of 2, which is nothing but P of M of 2. So now notice here that P of M of 2 means first we have to find the M of 2. So M of 2 is, how do I do that? I just plug it in x. For x I plug in 2. So I have cube root of 2 into 4, which is 8. So we have cube root of 8. And then negative 1 on the side. So now cube root of 8 is 2. So this gives me 2 minus 1, which is 1. So this is M of 2. Now we have to take this M of 2 and plug it in over here. So which means this becomes P of 1. And what is P of 1? Plug in, you get 1 minus 2 over 1 plus 2. So negative 1 over 3. That is our top. Now we work with the bottom. So the bottom is M plus P of 0. So which means M of 0 plus P of 0. To evaluate both quantities, M of 0 will be negative 1 plus M of P. So it will be also be negative 1, because when you plug in 0 for x, we end up getting negative 2 over 2, which is negative 1. We have negative 1 minus 1, so answer is negative 2. That is the quantity given here. So you got the idea. I think you should be able to do the next one. So similarly, again we have a top and a bottom. So we start with the top. So it will be M of negative 1/4 times P of negative 1/4. What is M of negative 1/4? Cube root of 4 into negative 1 over 4 minus 1, which is cube root of negative 1 minus 1. Now cube root of negative 1 is negative 1 minus 1, so I get minus 2. Now P of negative 1/4. So this will be negative 1 over 4 minus 2 and negative 1 over 4 plus 2. So take the common denominator, which is 4. We can always put a 1 under this, or we can multiply top and bottom by 4 and things get simpler. Well, anyhow, so I'm going to take the common denominator, which is 4 here. So on the top I have negative 1 minus 8. And at the bottom, same thing, take the common denominator, I get negative 1 plus 8. So this is giving me negative 9 over 4 divided by 7 over 4. So we flip the second, remember the second fraction is flipped and it becomes a product. So it will be negative 9 over 4 times 4 over 7 or negative 9 over 7. That is P of negative 1/4. So the top becomes m of negative 1/4, which is negative 2 multiplied by negative 9/7, which will give me 18/7. Okay, now we look at the bottom. So the bottom is m minus p of 2. What does that mean? It means m of 2 minus p of 2. Okay, so we already found what's m of 2 before in the previous um, quantity that we calculated, but we can do it again. So m of 2 will be cube root of 8 minus 1, or 2 minus 1, or 1. And p of 2 will be now 2 minus 2 over 2 plus 2. So 0/4, which is 0. So that this quantity is equal to just 1 minus 0, which means 1. So that the given quantity mp negative 1/4 over m minus p of 2 will be equal to negative 9/7 divided by 1 or negative 9/7. Looking at a application problem, it says a spherical balloon is being inflated. The radius of the balloon is increasing at a rate of 3 centimeters per second. Find a function r of time that models the radius as a function of time. So r is for radius. So we are trying to find a formula for r of t. R depends on t. So how will you do that? Well, think about it. When it's 1 second, because it's 3 centimeters per second, in 1 second, it is increasing by 3 centimeters. In 2 seconds, it will be 6 centimeters. In 3 seconds, it will be 9 centimeters. So can you see what is happening here? I have time. So in t seconds, it will be 3 into t. So that's how we are getting these. 3 into 1 is 3, 3 into 2 is 6, 3 into 3 is 9. That's how we are getting these values. Which means r of t is equal to 3t. Then it says B part, find a volume V that models the volume V as a function of radius. So V is the volume. So we want to find V of R. V volume depending on R. The formula is 4/3 pi R cube. That is the formula for the volume of a sphere with radius R. Then next is find the function V composed with R. V composed with R. And what does this function represent? What do you think? So what will we do? In this case, our dependent variable is t, because remember R has the R depends on t. R has the independent variable t here, and the dependent is R. So this will can be written as V of R of t, which means wherever I have R, I will replace it by 3t. So 4/3 pi into 3t whole cube. So which gives me 4/3 pi into 3t whole cube. The cube of 3 is 27, cube of t is cube. So we end up getting V composed with R is equal to 4/3 pi into 27t cube Now 3 goes into 27 9 times. So I get 4 times 9 is 36. 36 by t cube. So what do we have now? A function of time. So what this composition, what this did is it changed the volume as a function of, from a function of r to a function of t. So this represents the volume of the volume in terms of time. The volume function or the volume as a function of time. That's what this represents. Okay, by the way, so we have been doing these problems f composed with g of 2, f composed with g of -5, so things like that, or g composed with f. But we were given function and we just plug them in. But we can also do them by using the graphs. So we are given the graph of two functions here. The blue one is for g and the red is for f. You can see the g here. This is g and this is f written here. So f is the red one, g is the blue one. So when I want to find f composed with g of 2, which means f of g of 2. So from the table, what is g of 2? This is g of 2. So we are looking here, 0. So we have f of 0. Okay, but what is f of 0? F of 0 is 2. So answer will be 2. So see, with the graph, it's pretty easy. Okay, now the next one is g of f of 0. G of f of 0. Now f of 0 is 2. We already saw f of 0 is 2. So we can g of 2 and g of 2 is 0. Okay. Next one is f composed with f of -2. So we can compose the function with itself. So this is f of -2, which means f of, now f of -2. So here we have -2, and then at this -2 the value is little bit less than -1. So let's say -0.8. And what is the value of f at -0.8? So a little bit over here, 2 point something is equal to 2.2. Now if you want to do g compose with g of 1, so this will be g of 1. So g of 1 is negative 0.8. Negative g of 1 is negative 0.7 or 0.6. So g of negative 0.6 will be almost -1. So this is how we can use the graphs to find the values. Okay, so that's it for chapter section 2.7.